Let xc of t be a continuous time periodic signal with the time period t. Suppose it is uniformly sampled with a sampling period of ts, different from the period of the signal, resulting in this discrete sequence. The question is, which of these four statements is going to be true? Will the signal always be periodic? Will it never be periodic? Will it be periodic only if t over ts is a rational number? Or two options for the time period of this signal. So if you've learned any basic course in Introduction to Signal Processing or Signals and Systems, a very common example would be looking at the sine signal, which has a period of 2 pi's. If we sample it with ts just equal 1, we'll be left with sine of n. This signal is not periodic because we're only allowed to substitute integers for n. We cannot substitute two integers that differ in exactly 2 pi. Okay, this is because the signal period 2 pi's over ts is not a rational number. So the solution is going to be D. It is going to be a periodic signal only if t over ts is a rational number, in which case we can find values to substitute in such that we have an exact multiple of this ratio.